Okay, we're going to work some practice problems on the 6 trig functions, and I'm taking these problems from page 280 in the textbook, and I'm going to start with number 9. Just rough sketch, much prettier in the textbook. 15. All right. So we're missing the this side up here. And I'm going to use the Pythagorean theorem to figure that out. So 15 squared plus 8 squared equals x squared. And to save a little bit of time, I'm going to go straight to the x equals 17. So the hypotenuse is 17. Now the directions tell us to find the values of the 6 trigonometric functions of this triangle. So we're going to remember our SOHCAHTOA. And then once we have the 3 main, we're going to go from there. So sine of theta, cosine, and tangent. All right. By definition, sine of any angle is opposite over hypotenuse. So the sine is going to be opposite over the hypotenuse. So that's 8 over 17. Cosine, by definition, is adjacent over hypotenuse. So that's going to be 15 over 17. And tangent, again by definition, is opposite over adjacent. So that's going to be 8 over 15. All right. So now we know that if we take the inverse of sine, that will give us cosecant. So sine theta to -1 is cosecant. So when I take anything to the power of -1, I'm going to go ahead and flip the ratio, because so cosecant of theta is equal to 17 over 8. Now cosine, I take the reciprocal, that's going to give me secant. So secant of theta is going to be 17 over 15, because now it's going to be hypotenuse over adjacent. And then tangent, I take the reciprocal as cotangent, and that's going to be 15 over 8. Okay, so now let's move on to the next one. So let's take a look at number 11. Same page. We've got 6, 8, 10, and this little triangle here. Boy, that's an ugly triangle. And I have 1.5, 2.5, and 2. All right. In the interest of full disclosure here, both this number and this number came from the Pythagorean theorem. I'm trying to save a little bit of time from that. If that's something that you need help with, please let me know and I will help you with that. All right, so in this one, it says to find the values for the 6 trigonometric functions and then to explain why the function values are the same. So let's start over here with this first triangle. So sine is going to be, sine of theta is going to be opposite over hypotenuse, so 6 over 10. But then I can reduce that to 3 over 5. Okay, cosine is adjacent over hypotenuse, so that's going to be 8 over 10, and I can reduce that to 4 over 5. Tangent theta is going to be opposite over adjacent, so 6 over 8. Take 2 out of each, that gives me 3 over 4. Okay, so now we know if sine is 3/5, then cosecant is going to be the reciprocal of that, so cosecant theta is 5 over 3. And if cosine is 4/5, then the reciprocal of that secant is going to be 5/4. And then tangent, if tangent is 3/4, then the reciprocal of that cotangent, theta, will be 4/3. Okay, so now let's look at this other triangle over here. And just a little bit more paper. Okay, so now let's look at this guy. And let's look for sine of theta. All right. So now I have sine of theta, and remember sine is opposite over hypotenuse. So that's going to be 1.5 over 2.5. Or maybe it'll be a little bit easier to see how it reduces if we write it as a fraction. So let's put this as 3/2, and let's put this as 5/2. Let's go ahead and rewrite that because it'll be easier to reduce without using a calculator or anything like that. So we're going to have opposite 3/2 over hypotenuse 5/2. There we go. And that reduces to 3/5. Then we have cosine of theta, which cosine is adjacent over hypotenuse. So adjacent angle is 2, hypotenuse is 5/2, and that then reduces to 4/5. If that's a little bit confusing because of the fraction and a fraction, you can remember you can always multiply and flip. So 2 times 2 over 5, and then that's where we get that 4/5. All right, so tangent is opposite over adjacent, so we're going to have 3/2 over 2, and so tangent is going to be 3/4. All right, so if we notice here, we're getting the same values, and if we get the same values for sine and cosine and tangent, then we're going to get the same values for secant, cosecant, and cotangent, because those reciprocals of these initial values are going to be the same. So let me just write them down as the directions ask me for them for each triangle. Okay. And then we're supposed to explain why the functions are the same. So because these triangles' corresponding sides are proportional, they have the same sine, cosine, and tangent values. So if I look at this, 2 times 4 gives me 8. 1.5 times 4 gives me 6. 2.5 times 4 gives me 10. So their side lengths are proportional, therefore their sine, cosine, and tangent values are the same.